Hello class, this is the next example of multivariable simultaneous equations. So yeah, let's get straight into it. I realized in the previous video I showed the same equation. This is now a different one. Yeah, so you can pause it and give it a go yourself. You can see the solution now. I'm going to reveal it. So if you don't want to see it spoiled, you can pause and try now. So here are the solutions in 3, 2, 1. There we go. Okay. Let's get straight to it. So remember, we're going to number them 1, 2, and 3. Whoops. 3. And we just begin pairing them. I'm going to take 1 and 2 together. Like so. And for this, this is just me personally, I always eliminate the third variable. You can eliminate any that you want, but I just choose to do the third variable. To do this, I'm going to multiply this by 4, multiply this by 3. Let's use a different color. So this equation will become 8p plus 8q plus 12r equals 20. This next one is going to be, 15p plus 9q minus 12r equals 27. Good. Let's just color code these. This was in orange. This one was in green. Good. So now we're going to eliminate r. To do that, I'm going to do an addition. So it's going to be 8 plus 15 is 23p. 8 plus 9 is 17q. R is eliminated. 20 plus 27 is 47. I'm going to label this equation number 4. I now take another 2 pairs. I'm going to take 1 and 3. And once again, I'm going to eliminate the third variable, r. Now, if you do choose to eliminate q in this one, you must also eliminate q in the next pair that you take. So you must choose to eliminate the same variable in both pairs that you choose. So to do this, I'm going to multiply this by 5 and this by 3. Okay, so it's going to become 10p plus 10q plus 15r equals 25. This will become 9p minus 15q minus 15r equals 90. Good. For this, I'm going to add them to eliminate r. So it becomes 19p minus 5q 0r equals 115. Let's label this equation number 5. We take equation 4 and equation 5, and now we have a system of 2 equations. And now we can eliminate these very simply. Oh, we all have prime numbers here. Let's make this simple. I'm going to multiply this by 5 and multiply this by 17. Definitely going to use a calculator here. 23 times 5, 115p plus 17 times 5 is 85. 47 times 5 is 235. So equals, 235. This one was in orange. and now in green. 19 times 17 that's going to be 323. 323p. Negative 5 times 17 is going to be 85 once again, so negative 85q equals 115 times 17, 1955. And now we eliminate q. We do that by doing addition. And once again, really big numbers, just using a calculator, adding these two, 115, 323 is 438p. This is going to eliminate, it's gone, is equal to, adding these two, 235 plus 1955 is 2190, and dividing by that value, divide 438. I do not believe it. It's going to be 5. It's a very neat number. It doesn't seem like this would become that. But once again, now that we have p, we just go back and substitute into 4 or 5. It doesn't matter which one. I prefer to choose the smaller value here. So taking from equation 5, oops, substituting 5, so 19 times 5 minus 5q, 115. Going to move this across straight away, so 115 take away 19 times 5 is going to be 20, so negative 5q equals 20, which means q equals negative 4. Once now we have that, we're going to take both and substitute both of them into any one of these values. The one with the smallest numbers is equation 1. So taking equation 1, ooh, where'd it go? Oh, sorry. Good. Equation 1 is here, and we're going to substitute q equals negative 4 and p equals 5. 2 times 5 is 10. 2 times negative 4 is negative 8, plus 3r equals 5. 2 equals 2 plus 3r equals 5. Oh, seems like we got a wrong substitution here. Oh no, sorry. 3r equals 3, r equals 1. Oh, sorry. In my head I had 7 over 3. But regardless, that is now the solutions. So p equals 5, q equals negative 4, r equals 1. And there we have it. So I hope that gave you an insight into another example of solving simultaneous equations with more than 2 variables using elimination and substitution. I hope to see you in the next video. Best of luck.